So there is an instruction which is called, which we have discussed in the instruction set, which is called ADC. ADC means addition with carry. Fine. So the moment we are adding two registers, one will be acting like source and another one which will be acting like your destination. Alright, so ADC will be what? Destination register plus source register plus the carry flag. This is how this thing will operate. Fine, so I'm loading two values in register A and register B. Fine. So and then I'll be trying to use ADC, but in order to get a carry, let's use an instruction so that I could be able to use the carry in that as well, and then we'll see what will happen in the instruction. All right, so in these, first instruction is your first value. You can write comment by using a semicolon. This is your second value. Next we have is here we are setting carry flag to utilize in the operation. Then we are having what? With carry. So let's see how this program is going to operate. So let's emulate this thing. And it again pops up two windows and they must not be visible on your screen. So let me all right, so as you know, there are two windows that comes after clicking on emulator. So let's go step by step. First instruction is loading bx with 1 2 3 4. Bx is right now 0. Let's load 1 2 3 4 loaded. Next is AX getting loaded with 1 2 5 6. AX 1 2 5 6 loaded. Now we have to see what is going to happen with the flags. Currently the carry flag is 0. I have seen by clicking on the view, the current state of carry flag is 0. So let's execute. Now you can see the carry flag is set after execution of STC. That was like this. So the moment I'm going to add this thing, AX with BX, what answer am I supposed to have? Anyone tell me? 1 2 3 4 plus 1 2 5 6. What answer am I supposed to have? Anyone?
248 AH.
Yes, 248 AH in general. Fine. And what am I going to have as the answer is to look into the A register now. Where I'm hovering my mouse, the answer coming out is what? 248A. But the original answer should have been 8A. Sorry, the answer should have been 248A. So from where you are getting +1, the +1 was coming from the contents of carry flag. Fine. So now you can see what happened in this. 1 2 3 4 added with 1 2 5 6, and the answer which came out is 6 plus 4 10. That means hexa. 5 plus 3 8. 2 plus 2 4. 1 plus 1 2. 248A was supposed to be the answer, but what happened? It came 248B because the carry was 1 and it has been added. So the answer comes out to be 248B. So this is how addition with carry takes place. Addition with carry takes place. ADC. Fine. Is that clear?
Yes, sir.
Fine. So let's do one more, which is a little typical one. Subtraction with borrow. Subtraction with borrow. Okay, so I use the same instructions, but let's do it in that way. Uh, we can set the carry, but I want to set the carry in a different way, because subtraction with borrow is another form of having the carry. Let's see if this is going to help us or not. Okay then, so BX loaded, AX loaded. Let's check out the flag. Carry flag 1, subtraction with borrow. Fine, so now what we have here is BX loaded with 1, 2, 3, 4, AX loaded with 1, 2, 5, 6. So let's see what answer are we going to have. The answer we are going to have is FFDD. Let's take one more example. So let's talk about stack now. So I'll be using some instructions to put some value onto the stack and to retrieve some value to the from the stack. So let's use push. So push will be pushing something up to the top of stack. Fine. So let's say I'm going to push the contents of BX to the stack. Let's emulate this thing. So let's see what's going to happen here. Fine. So where we have stack, look into the bottom of this what you say emulator window. Into the bottom here we are having screen, source, reset, aux, where's, debug and stack. By clicking on this stack, it will show you the stack register or stack memory, you can say. Why this is so? I can't move it. Okay, let's attach it here. So let's go step by step. So this is your stack 0100. Triple FE is the first location we are having. So first instruction executed, B has been loaded with 1, 2, 3, 4. A has been loaded with 1, 2, 5, 6. Now if everything is fine, the value of BX, which is 1, 2, 3, 4, it will be pushed into this stack. So let's see, is it going to happen? See, the value 1234 which has been loaded inside the register B, it has been loaded in this 1234. The location is FFC. Are you able to see that the value has been pushed into the stack? And this is the pointer. That blue highlight at that symbol is your pointer. Fine. So what happens is we just push the value onto the stack. So let's move it. Let's do it again, and let's add one more instruction where I can pop also. So let's pop a value into the register C. So wherever the stack is currently pointing, that value will be retrieved back into register C. So let's emulate this thing. Get stack. Fine. So let's go step by step. BX value loaded, AX value loaded. Now we are going to push something onto the stack currently pointing at the top location. The contents of BX has been pushed. Now you can see 1234 has been loaded into the stack. Next is we are popping or retrieving back to CX. Currently CX is 0, and if everything is fine and pointer of stack is currently pointing at 1234. If everything goes fine, the C will be having 1234. Let's see that. Yes, everything went fine. We have popped the value from top of stack to register C. Are you able to see that? The value from that top of stack into register C. This is what we mean by the pop. Push and pop. Is it clear?
Yes, sir.
Okay then. So there are many examples we'll do on the regular basis. I'll devote 2-3 classes for this programming stuff only. So let me show you one more thing, the memory structure. So by clicking on the bottom, there is one option called aux. Once you click on aux, you will be able to see the memory, ALU, FPU, stop on condition, the symbol table. The first, if you click on the first memory, this is where everything is running. This is your memory. Fine. So what we are able to see here, 0100, 0100, this is the segment address of the code segment 0100. Fine. And currently something is pointed out, 00. This is the logical address which is being seen here. Fine. And if you want to change it, you want to check any other physical address, you can also change it, and you can just click on update and it will show you the respective value within that. So let's see, 0100, I just updated this to a new offset 2003. So segment is this, and inside the segment this is 2003, and this is the particular value which is not having any value, it's just empty. Fine. So what we can see in these also, that every time you click on here in this middle window, which is what we call the binary window, okay, so by this you can see that 0100 is the segment starting, or it is the code segment value. Fine, the starting address of the code segment, and 0002 or this place. So by looking at this, you can easily see that what is the physical address. So if 0100 is the segment starting and this is the offset, what will be the physical address? 010002. This will be the physical address. So these locations which are shown in this binary window where your conversions are being stored, it is here. Okay, so there are many things we'll see in between while doing so much of programming. For the time being, I'll also suggest start practicing in this EMU 8086 and do some practice with your basic programs.